This is MBF3C, grade 11 college prep math. I'm Pete, I'm your teacher, and here we are with the next lesson in our study of geometry, trigonometry, and we're going to learn, I call it the decryptonite of triangles yesterday, because if you have a triangle and you need to find some information about it, and it's not a right triangle and the law of sines doesn't work for you, then this next one will work for you. So what I talked about yesterday was that we might take a bit more time on the sine law, but actually I think we got through that whole thing. So if you did have some questions about this, the sine law, you're certainly welcome to ask them. But I'm just going to move on right now. So we're on lesson 13 of Unit 3. Okay, we're going to wrap up Unit 3 next week, and so make sure that you have a copy of Unit 4, the last unit in the course. That you're going to need that. Probably going to need that on Thursday. We'll see how things go. Okay. All right, let's see here. So this is lesson 13, and it's a law of cosines, and or the cosine law, I think is the way I kind of say it. There's different ways of saying it. So that's going to be on page 27, where it really starts. So that's going to be unit 3, and it's page 27. Now, the sine law was just a ratio. Okay, it was just the sine of an angle divided by the length of the opposite side equals the sine of some other angle in the triangle divided by the length of the opposite side. They're pretty straightforward. So whenever we can, we try and use the sine law. But sometimes we don't have enough information, and the specific piece of information that we can't figure out is the length of a missing side. Okay, and that's where you'll find that the cosine law comes into play. Because if we're missing an angle, if we have two sides and one angle, we can use the sine law to find that, right? If we don't have any angles, we're kind of stuck with the sine law. If we have one angle, we may be able to work something out. But anyway, let's take a look at the sine law, the cosine law, and see what they have to say. So this is page 27. So it says the cosine law is used to find the third side of a triangle when two sides and a contained angle are known, or to find an angle measure when the length of three sides are known. So there's the other case where you'll be breaking out the kryptonite, the law of cosines, is if you have a triangle and you know all three sides, but you don't know any of the angles, right? So you can use the law of cosines to get you one of the angles, and then you could use the sine law to get you the second angle, and then you could use the sum of the interior angles, add up to 180 degrees property to get you the third angle. So you can just work your way through all the laws. Now, of course, you could use the law of cosines to get you all three angles, but as you can see, it's a bit of a beast of a formula. In the text, they give you three different variations of it. Personally, I wouldn't learn these by heart. What I would do is learn the pattern. Okay, I'd learn the pattern of them. And once you got the pattern down, you don't have to memorize three different variations of it. Okay, so the pattern is, so for a triangle ABC, so it's big A, big B, big C are the angles, and the little letters are the sides. The length of the C squared, so the length of one of the sides is equal to the square of the length of one of the sides is equal to the sum of the squares of the other two sides minus 2 times the length of the other two sides times the cos of the angle opposite the side you're trying to find. That's what it's saying. If you learn that pattern, you can't go wrong. The side you're trying to find only shows up on the left side because that's what you're trying to find. The cosine of the angle opposite that side shows up in the formula. And then the only other sides that show up are the sides that aren't the one you're trying to find. So A and B, the other two sides. So we have a squared plus b squared minus, and then 2 times ab, which is 2 times the other two sides. Now, if this looks a little bit like the Pythagorean theorem, I think you might be on an interesting thought process there, right? All we would need is for something in this last little piece to make that equal to 0, and then we'd have the Pythagorean theorem. So I wonder what the cos of 90 degrees is. Anyway, you can check that for yourself. So that's it. Now they've given the other two variations, but those are just like if you're trying to find B, then your two sides are going to be A and C that you use, and you're going to use the cos of the angle opposite the side you're trying to find. Okay, so this is why I'm trying to emphasize that you don't have to memorize 3 different variations. Just memorize the pattern. Write down the side you're trying to find squared equals, and then the lengths of the two sides you're not trying to find squared minus 2 times the length of those sides you're not trying to find times the cos of the angle opposite the side you're trying to find. That's it. Okay. Now there is another variation of this which involves it's when you're trying to find the cos. It's when you're trying to find the angle, right? If you have a bunch of sides and you need an angle, so you have 3 sides and you need an angle. Okay, that's basically when you're going to use it. So there is a sort of a manipulation of this, and yeah, it works. It's fine. We can do it through our basic algebra skills that we have, and we're going to practice doing that. But they also give it in the text in just a slightly different organization. Okay, example 1. Find the missing side shown in the diagram below using the cosine law. Well, oh, isn't this lovely? The diagram is on the next page. Okay, yeah, we need to work on some of this. So this is on page 28. Let's take a look on page 28. So they just want us to find the missing side. Now remember that trigonometry, geometry is all about measuring things. So as usual, we're gonna add some units to the diagram. They should have units. So we're gonna work in meters. It doesn't matter what you're gonna work in. If you're going to be doing this, though, your units have to be consistent, right? If one was meters, one was centimeters, you need to convert one of them to a common, they both have to be in the same units. So, meters and centimeters would probably just multiply by 100 to get the centimeter one into meters. And then degrees for the angle. So let's take a look at this. If we tried to solve this problem right now using the sine law, okay, we would have the sine of 118 degrees over A equals, and now you see the problem is we don't have another angle. And we can't figure out another angle because we don't have enough, right? If we were only missing one angle, we could work it out. So that's where the cosine law comes into play. Okay. So we're trying to figure out A here, but we have enough stuff to use the cosine law. Okay. So I'm just going to go ahead and do it. They show it right there. But there's enough room over here on the side. So let's first, we want to find A. So we're going to say A squared equals. Now, it's the square of the other two angles. Or, sorry, don't say angles. It's the square of the other two sides that we're looking at. So we need B. I mean, it doesn't matter what order we do it in, but I'll do it in order. So it's 16. That's the one there, plus, and then the other one, 11. I mean, really what it is the two you have. You just stick them in there, right? Minus 2 times 16 times 11, which are the two you have. And then the cos of angle A, which in this case is 118 degrees. And I managed to fit that all in there. Now, if you look at this equation, like I said, this is the trigonometry equivalent of kryptonite, because there's nothing that we can't figure out with this particular formula. It's just longer than it needs to be if we have a bit more information. So we have everything we need on the left hand, let's see, we have everything we need on the right hand side. As long as we plug this into our calculator correctly, we should be good. Okay, so I'm gonna leave it a squared. Just don't forget that. That's the sort of little thing that can kind of go horribly wrong. You forget to take the square root of the thing. You forget to square those two numbers. You know, all sorts of things can happen. But if you are working on this and um, you get that formula correct, you get your diagram correct, you're going to get most of the marks anyway. All right. Because the familiarity with the um, with what to expect when you're doing this formula is, and then it's negative 165.2539901. Do watch that, because we have a negative number in there. You know how to deal with that from your algebra. That becomes an addition. Okay. So okay, and I have 542. 0.25, and then we look at these units, and really we can't justify um, having any more than one whole unit there, because we didn't start with fractions of a unit. Oh wait, I'm not quite done yet. Okay, so let's just back up a little bit, because take a look here, a squared. So a equals the square root of 542.25. Yeah, well, that makes sense. These are small numbers on that triangle. So I just find the square root of that on my calculator, and again, so it's going to be 23.27 to 2 decimal places, but really we want to just call it 23 meters. Okay, so how did I do compared to what they found? Oh, they put it to 1 decimal place, but my position on that would be that you don't have 1 decimal place of precision in the original data. You can't really say that. You're claiming that it's accurate to 10 centimeters when your original measurements were only accurate to 100 centimeters. Okay. So, but you see how you do it, and it's a pretty straightforward thing. This little bit in the middle here could be a little confusing, but you know what? If you just type it all into your calculator in order, it'll probably just work it out for you. Anyway, try it. Make sure your calculator doesn't have any quirks with the order of operations, right? Another way to do it is just to kind of do this part first, and then multiply it by -1, and then add the other two numbers. That's another way of kind of working your way through it. All right, well, that was a case where we were trying to find a missing side, which is the pretty typical way of using the law of cosines. Now, things get a little more ugly when we're trying to find an angle with it, because we have to rearrange the formula. Okay, so they, I'm sure, have a very clever way of manipulating the formula. So I'm going to show you how that works before we get too far into it. So I'm going to make a, this is example 2. All right, so this is example 2 on page, page 28, I guess, is what it's going to be. Okay, so we want to be able to find the cosine of A. So that means that we're going to use the version of the formula that has a cosine A in it, which is just the one that we started with in the last time. I'll change to blue here. So we're going to start with A squared equals B squared plus C squared minus 2AB cos A. So what our goal here is to use our algebra skills to get that cos A all by itself. Okay, so we want something that basically says cos A equals. Okay. So how are we going to do that? Well, we can't, up until now we've been using some, sorry, that's a plus sign there. Here, I'm just going to Here's going to fix it up a little bit. It's looking a little haggard, that plus sign. Okay, so when we've been doing some of these with the sine law, there were no additions or subtractions involved, so we just simply multiply and divide. But in this case, we really need to kind of get some stuff um, on the other side of the equal sign. So, for example, if I have a squared over here and I want to move the b squared, I have to subtract like that equals minus 2ab cos A. Okay, so far so good, right? Now, one of the things that's going to help us here is if we get rid of this negative sign right here. So what I'm going to do is I'm going to multiply both sides by -1. Okay, -1. Okay, so what that does on the left side, that would be the right side, is just changes this to 2ab cos A. And on the right side here, it basically flips all the signs around. And this is where the book gets a little plus c squared. See, we've been through this before. If you wanted to use the distributive property, you would find out that it does indeed do this. That's a really lousy looking A. Sorry about that. Okay, I didn't make it any better. And it still looks terrible. All right. So what they do in the book, I think, is they're going to just rearrange things just so that they don't have that leading A right there. You know, it's, I probably wouldn't really notice it, but I noticed that they did that in the book, so we'll just leave it that way. Okay, now the only other thing we need then, and now we're good, right? Because all we have to do is get rid of that 2ab, and we can do that by dividing both sides by 2ab. So when I do that, then what we end up with is b squared plus c squared minus a squared over 2ab equals cos A, right? So we divided both sides by cos A. So that's where we ended up. And why do we have 2BC here? 2BC. You know what? I think what did I do? Oh, okay. How did I, yeah, BC. Somewhere up here, my B and my C ended up being an A and a B. That should be B and C. Sorry about that. All right, let's try it again. That's a BC. That's a BC. That's a BC. That's a BC. And that's a BC. Okay, does this make more sense? Okay, sorry about that. So now, here's what I want to sort of say about this sort of thing, is that you see how quickly I fixed that mistake? Like, everything in math is a rough draft, right? Once you recognize, oh yeah, okay, I did something wrong, you don't have to start over, you don't have to erase anything, you don't have to crumple up your paper and throw it away. To go back and fix it. And in order to be able to go back and fix it, it has to be written out in a way that's that's useful to you, right? That you can go back and see where you made your mistake, right? Okay, so there you go. I'll what I'm going to do, just to make it a little clearer, I'll just put that here, and that's going to be 2BC. Now I think my order, I think I got the B squared and the C squared different from the text, but this will show you how I got to this, so that you don't really have to memorize that second formula. You can, right? And if you use it enough, you'll memorize it anyway. But you can double check and make sure that you got the right formula. Okay? So now we have a formula here that we can use from now on to be able to find an angle given three sides. And that's the secret to this, that we really need to have three sides in order to be able to solve an angle in using the law of cosines. Okay, so now let's go ahead and plug that in then. So the triangle that they had here was this. All right, so it's A, B, C. I'm just going to change colors here. And it was 23, let's call it meters, 20 meters, and 27 meters. Okay, so, and that's the type of thing. Imagine trying to do something with that with the law of sines. You can't do a thing with it. You don't have a side, or sorry, an angle, right? And we can't even do anything with it. You know, maybe back in grade 8 or grade 9, you might have even seen a teacher. You know, they'll drop a perpendicular down and then turn it into two right angles, right? Well, you still don't have enough information. You don't have any angles at all. You can't, right? You just, there's nothing to do there with our standard method. So this is where we're going to use our formula that we just derived, which is the law of cosines. It's just been kind of turned around a little bit to allow us to find a cosine of an angle. All right, let's try it. Now remember, I'm going to write it out. I'm going to say cos, oh, I don't know how I ended up with green, but anyway, cos A. Remember that this equal sign means equal, so I can put the cos A on the left if I want. Yeah, why not? It's my equation. I can do what I want. I could just solve it with the cos on the right, but I don't know, maybe yeah, it might bother someone. Okay, so there we go. So now all I have to do is plug in all of this information, all the b's and everything. I'm going to extend the page a little bit. Sorry about that. And so here we go. So cos A. Now remember, it is the cosine of A. So we're going to have to take the inverse cosine at the end. Remember how the last one I had to find the square root and I almost forgot? Well, again, we will know because we're going to get some really weird number that doesn't match an angle. And that'll kind of, if I forget, then I'll look at it and go, that's probably not an actual angle we're looking at. Okay. So let's see, b squared. So this is our b right here. So our b squared is going to be 23 squared plus c squared. That's going to be 27 squared minus a squared, which is 20 squared, over 2 times b, which is 23, times c, which is 27. And make sure you get those ones, because if you get, like, if you accidentally get an A down here, yeah, ugly things happen. You get an answer that looks good, and it can be really hard to sort of see what happened there. All right, so the cosine of A equals, now you can do this in however you want. These are all just straight up. You're just squaring a bunch of things, and so it's 23 squared plus 27 squared minus 20 squared. Now, don't, you may end up with, you shouldn't end up with a negative number. That's what I'm saying here. So I got 858. With the tangent, if you're doing something with the tangent ratio, you could end up with a negative number, but for this, you should end up with a straight up positive number going into cos. 23 times 27. You see that? Now we're right back to where we were back in lesson 11. We have a ratio that represents the cosine of an angle. And so if we want that angle A, then we're going to do the inverse cosine. Look at that. 858 divided by 1, 2, 4, 2. I got to extend this page here. All right. The suspense is... Okay, so I'm going to do that. So it's 858 divided by 1, 2, 4, 2. And I got that. And then I'm going to take the inverse cos of that. And I got 46 point, well, it's 30. We sort of rounded off to what, 46 degrees? Something like that. Okay, what did they come up with in the book here? Oh, look at that. They came up with 46 degrees. All right. Now, remember that I got that 46 degrees by first deriving the formula. I didn't use the one that they showed us in the book. I think that some of my terms are changed around a little bit, but mathematically I have the same answer, and mathematically the formula is the same. B squared plus C squared is the same as C squared plus B squared. So that's all it came out. So there you go. So what does this actually mean? This means that angle A is 46 degrees. Let's go have a look. Let's go educate our diagram. That's 46 degrees now. Well, now what can I do? I can now use the law of sines to find either C or B. I have enough information, right? Okay. And then once I found either C or B, angle C or B, now I have enough information I can use to sum of the interior angles, being 180 rule, to just subtract the two other angles from 180, and boom, I got the third angle. Okay, so like I said, this is the mathematical equivalent of kryptonite here, the law of cosines. Okay, that's going to get you through any triangle. Hopefully you don't have to trot it out too often because it's a fairly long formula. Okay, that's why we don't use it all the time. It's just because it's a long formula. Okay, I think, where are we here? So, I don't think we're going to spend too much time because it only has two tricks. It can find you a side and it can find you an angle. That's it. But when you need it, you need it. So let's take a look at the support questions and we'll try these out here. Okay, find the length of the side of the indicated side. This is on the top of page 30. Okay, support questions. All right, let's try this one. So now it's a length, so we're just going to use the regular format of it. So let's see, it's a length. So it's the x, right? So that's little c, but we can call it x squared, yeah, equals, all right, what do we got? We got little a, which is 50 squared, plus little b, which is 30 squared, minus 2 times 50 times 30, and then the cos of the side opposite little x here, which is going to be 100 degrees. So there we are. I think we got everything we need right there. Oh, looks good, right? Okay. Yeah. So, and you see the pattern, right? It doesn't really matter what we call this, as long as this cos is the angle opposite that, and then it's going to be this squared plus that squared minus 2 times this square, this times that, right? Okay. So let's try it. Okay, I'm just going to plug all that in. So 50 squared plus 30 squared minus 2 times 50 times 30 times the cosine of 100. Boom, there we go. And I get something that's like 3920.94453. What x is equal to the square root of that thing. 29, no, that's a 0. And we could write that out, but really, we just have to get it back here. So just say x equals, and I'll just find the square root of that. Second square root. Very often your calculator will let you find the square root of something you just calculated. You just have to kind of look at it and try and work it out. That's 62.62 meters, and we really have to, really by rights we should only call it 63 meters. Okay, the rounding. Okay, so that's it. Now if you wanted to double check, you go to the back of unit 3 here, and so this is it's going to be lesson 13. Yeah, is it lesson 13? Support question 1. Okay. Lesson 13. Well, 62.6, and we just abbreviated it to, rounded it to 63. Okay. All right. So that's the first one. I'll do the second one because it's also finding a measure of an angle. So we have to use the alternate version of our equation here. Okay, so what I'm going to do, there's no room on the sheet, so I'm just going to make a new page here. So, but you can stay on page 30 of the handout. Okay, the unit 3. So this is page 30. It's unit 3. Unit 3. All right, find the measure of x. So, and this is support question 2. So the the triangle, you know, and it's just a triangle. They're so let's okay. So that's 17. We'll call it that. Let's call it uh, centimeters. Why not? And 35 centimeters and 28 centimeters. It doesn't matter what the units are as long as they're consistent. And they want us to find x right here. That's the angle they want us to find. Okay. So we can derive the formula again. If you have it written down in your notes, you just go ahead and use it. But why not? Let's just, it's going to be something like x squared. Ooh, I'm going to fix that a little bit. Okay, so it'll be x squared equals, now in this case, we have, so it's going to be 17 squared plus 35 squared. Wait a second. No, that's not, I was sort of thinking that we would put x in there. Let's see, how am I going to do this? Because we don't have sides here, so, you know, I could just, I could label everything x, y, z or something, and then we could start working with variables. But why not just, let's just grab the formula that they give you. Actually, yeah. So cos x is going to be, yeah, you see we don't, b squared. So, b squared, okay, so how about this? It's going to be 17 squared plus 35 squared minus 28 squared. Now, where did I get the 20? Why did I pick 28? Because that's the angle opposite x, or the side opposite x, and that one has to, that's the one you subtract, and then it's 2 times the other 2. So it's 2 times 17 and 35. Okay, so that's the whole thing. What I was kind of struggling with is that I tend to, when I'm doing these kinds of things, to write down the formula first with the variables in it. The problem is here is that the question didn't give any side, like it didn't designate any angles. All we had was x, plus we had the sides. So, you know, the struggle there is, do we add a bunch of stuff to the diagram just for the sake of presenting the formula, or can we just jump into the formula with the numbers with both feet? So I finally, I guess, decided to do the second part, and so that's how we find the x, the value of x, is if we just crank through all of those calculations. Okay, so we'll try this. So I'll just do the numerator and the denominator separately. So it's 17 squared. So it's basically the sum of the squares of the two sides that are not the one we're opposite the angle we're trying to find, minus the square of the side opposite, the side that we're trying to find. If that makes sense. Okay. Okay, and so that's 730 up there. Now, if you get a negative up there, chances are things, you know, it's not correct, because you definitely need this. The only way that that could be negative, um, that can't be negative, because you can't turn the denominator negative to fix it. So we're definitely talking about, it has to be positive. So it means that you have them in the wrong order, basically, if it's negative on top. 1190. So there we go. So then x is going to be the inverse cos of this 1190. Okay. So there we are. Okay. So cos 730 divided by 1190. Okay. And so inverse cos. Oh, let me just try that. I had meant to do inverse cos, and for whatever reason, when I pressed the function button, it didn't. It gave me cos. I didn't press the function button hard enough, I guess. And so we get 552 degrees. It's approximately. We just kind of make those squiggly brackets. Oops. All right. So approximately equal to 52 degrees. Okay, so then I would go change colors here, and that means that the value of that is 52 degrees. So now I'm on my way, because now I can figure out another angle with the sine law, and so on and so on. Okay, now just to double check, let's see what the book had to say. This is lesson 13, support question 2. And yeah, they get 52.2 degrees. I'm still sticking to the fact that if they give us numbers that are to a whole unit, there are no decimals at all, we really can't give decimal numbers. It's giving a false impression of accuracy. And that really is important if you're going to go on into, maybe you're going to work in a lab somewhere, you're going to work in a veterinary clinic, or even if you're working like in automotive where you're taking measurements, like say you're trying to straighten a truck frame that's been bent, right, and you're taking measurements. If you're giving them 6 decimal places of accuracy when you were measuring everything to the nearest centimeters, that's really false advertising, isn't it? Okay, or milliliters, and then when in fact it's to the nearest liter or half a liter or something. Okay, so that was the first 2 support questions, and what we'll do is we'll find what the next. Let's just take a look at a couple more support questions here. All right. So as a matter of fact, we can really probably spend some more time on this on Monday when we come back as well, because I want to make sure that this is all straight and all solid before we move on, because the next lesson 14 is just really where they just give you a bunch of problems, and then you have to figure out which of your tools that you're going to use, right? So we're just going to want to make sure that you're really comfortable with this one before we move on. Okay. So just gotta, okay. So, and this is, all right. Now these lessons, they're posted in the WASA archive. So you can always go to the WASA archive. The other place that they are is in my YouTube channel, PW space WASA. So you can go onto my YouTube channel. Now sometimes I post them every couple of days. I don't post them necessarily every day. If you were looking for a particular one and it wasn't posted yet, just send me a message and I'll get to it a little faster. It just, for me, I just post a few of them at a time. Sort of a task to do in my routine. So yeah, so you can always go back and look at these. The other thing you could do also is there's some from last semester, so you can always go back to last semester and just kind of poke around them, and you usually find out where we are. Just look at a little bit of it and you'll see where we are. Okay, whoops, okay, those are the key questions. So we'll take a look at the key questions probably on Monday. But let's take a look at some of these other ones. Now, we don't necessarily have to do all of these. We can do a few of them. So, in triangle PQR, find the value of R. So R is, we're looking for a side there. We're looking for a side in number 4. And in number 5, we're looking for an angle. Okay, so you see how the variations are. Okay. Now, question 7 is kind of an interesting question, because they kind of want you to know a little bit about baseball, eh? Let's try that one, because this is the sort of question. Oh, wait, why am I? Oh, sorry. I just grabbed the wrong page from the book here. Okay. So yeah, if there was some talk about putting a camera in here, how would you feel about that? Being able to see me grab the wrong page from my book. That would probably make things even funnier than they are. So we're on page 30. This is support question 7. Um, and then it's, yeah, so that's page 30. So what it says, the faces of a softball diamond are 15 meters apart. So you have to know what a softball diamond is, I think, right? So now I had to look this up. So, so this is, well, we know what a diamond looks like. And if you turn your head sideways, it's really a square, isn't it? That's a terrible looking diamond too. You know what? I'm gonna try that again. Sorry. Yeah, I've drawn lots and lots of squares in my day. I think I can do this. Might take a few tries. Okay, well that's a marginally better looking diamond. That was worth the effort. So we have a diamond. They're 15 meters apart. So what is this telling me? So what the way the softball diamond works is this is the home base right here, and then this is the first plate. No, first base. That's first base. That's second base. That's third base over here. So that's your baseball diamond. Okay. Now they're 15 meters apart. So this is 15, right? And they're all 15 meters apart. That's what they're saying. Oop, 15. All right, 15 meters. Yeah, and then that's 15. I don't know if we need that or not, but that's what it says. A player picks up a fair ground ball 3 meters from third base along the line from second to third base. Yeah, you really have to be an expert at playing baseball to answer this question. Well, there's second base, there's third base, and it's 3 meters from third base. Okay, so there's the player's right there. All right, so there's the player. Okay, and that's probably 3 meters. Okay. Along the line from second to third base, got it. How far must he throw to first base? Okay. Is that it? Is that what gonna? Okay. Well, okay. You see, now this makes sense, right? So basically, I guess it's a he, is he grabs his ball and has to throw it from where they are at that red blob there over to him. So let's redraw this. Okay, now there's no harm in redrawing the diagram once, because remember the 4-step problem solving model. Step 1 is understanding the problem. Well, we don't always necessarily understand the problem the first time we draw our diagram. We're just throwing some stuff down. Okay, but now what this means is that we have this triangle, and oops. All right, you know what I'm going to do? I'm going to erase that. Even though I'm happy with that triangle, I'm going to make it a little closer to the triangle we're dealing with, just because otherwise it could be just a little confusing. Okay, whoop. Okay, well, I didn't. Okay, so this is our 15. This is our 15 meters. This is first base. This is second base. Now this point here is the point where the player throws the ball, right? This would be third base right here, but it doesn't really come into play because this is the new triangle we have, where this length, the side length between, we could call this A right here, A, B, and C. The side length AB is 15 minus the 3 meters, right? It's 3 meters. This is the base here, and I think it says 3 meters yeah, it's 3 meters from third base. So that's 3 meters right there, which means this is 15 minus 3. That's got to be 12 meters. You see? You got it? Okay. Okay, I think so. And then what we're trying to find then is this one right here. This is X. Yeah. Okay. Maybe I should have might have been a little easier to name these other. Well, it doesn't. We're not bound by those yet. Okay. So what else do we need to know? We don't have You know what we don't have is we need an angle. Let's go back to our original diagram. Remember, this is a baseball diamond, and I think, I'm not positive, but I think the baseball diamond, I think that those are right angles. Is that correct? Huh? Okay. We might have to look that up on the internet, but I think so. Yeah, well, I'm going to assume they're right angles. Okay, if it turns out that they aren't, then we'll be in trouble. Well, wait a second. If I assume that that's a right angle, hmm, then this is not a law of cosines type problem, is it? Okay, well, what else can I assume then? Yeah, I don't think I really have much. Oh yeah, they do. They have to be right angles because these. Oh, I know. Um, yeah. Let's see. Those are 15 and 15. I'm just trying to think if there's a way to, um, because I can say on the original diagram, if that's the same length as that, then I can tell you that this angle and that angle are the same. I don't know if that helps us here. What do you think? Okay. So, oh, it's a good question, isn't it? So if we assume that that's a square, yeah, I think we pretty much have to assume because they're all 15 meters apart. So basically it's a square, so the corners have to be right angles. But if that's the case, then this is not really a law of cosines problem. So I'm not really sure. Um, let's see. A player picks up a fair ground ball. Well, let's try it. We'll try it this way and see if our assumptions hold out. Okay, so well, if that's 90 degrees, it doesn't really look like a very, I just didn't draw it properly to be 90 degrees. So then really this is just going to be a Pythagorean theorem type question, isn't it? So x squared equals 12 squared plus 15 squared. Now the reason for that is if we were to use the law of cosines, maybe that's what they want you to do. If you went to minus 2 times 12 times 15 cos big X, which is 90 degrees, what you would find if you try that is that that whole expression becomes zero because the cos of 90 degrees is zero, right? So yeah, I think that's probably what they're trying to show you. So this whole thing then becomes zero, meaning that it just sort of is reduced to the Pythagorean theorem. I think that's probably what they're trying to show you there. Okay. Squared. So it shows you that a knowledge of sports is pretty important, apparently, in mathematics. You've got a bunch of golf questions in here, too. So we're going to, yeah, I think in the key question, there's some golf questions. Okay, so x is equal to the square root of this, 144 plus, 15 squared. Yeah. Okay. It's going to be 225. 225. Okay, x equals and 19.21, which is approximately 19 meters. You know, that seems about right, doesn't it? I'm just going to write it in black on here. 19 meters across the diagonal of the baseball diamond. That seems about right. Let's take a look at what the book says and see if we're right here. And you know, this could be fun. Um, and here's the thing. Being right is okay, but actually being wrong is where you could sometimes learn stuff in math. Okay, so we're in Unit 3. I just got to find less than 12, and this was question 7. So I'm just going to look this up. Question 7, 19.2 meters. So yeah, so we got it. So I was correct in that, assuming, and it makes sense that those are 90-degree angles. And I think that this is what they wanted you to see, was that even if you use the law of cosines to try and find this out, this angle, that because the cos 90 degrees is 0, it's just 0 times everything else in here, and it just eliminates that expression entirely, and you're left with the Pythagorean theorem. Okay, whenever you have a right triangle. Now notice in this case I didn't really draw it properly, the right triangle. Really it probably should have, whoops, okay, well, it probably should have looked something like that, a bit more like that. But anyway, managed to work our way through it. Okay, so now it has, so question 8 is just a side question. Oh, here's a good question that'll, we can probably leave this until, we'll leave off with this. Okay, and this question is, I'm just going to start another page here. So this is support question number 9 on page 30. A plane leaves Hamilton and flies due east. Now this is where they kind of, it's a little, if you look at a compass, the directions, we got your north, we got your south, we got east, and we got west. So what they're sort of saying is east, that's what they're talking about, right? So the plane leaves Hamilton, let's call that H, and it flies due east. There you go. For 75 kilometers. There we go, 75 kilometers. At the same time, a second plane flies in a direction 40 degrees southeast. Oh man, southeast. So southeast. Well, southeast is midway between south and east. And if we know that that's 90 degrees, then it means that our angle, our southeast angle here, is going to be 45 degrees. You just have to kind of know that. There's no real, it's just something you kind of have to be familiar with. It flies in a direction, oh, it tells you. It doesn't say southeast, it just says 40 degrees southeast. Sorry about that. If it just said southeast, it would be 45. So it's actually giving you that angle right there. All right, 120 kilometers. So that's 120 kilometers. Okay, let's move that up above. Okay. How far apart are the planes when they reach your destination? So this is what they're trying to, this is what we're going to do. I'm going to write this one in blue here. There you go. So that's going to be our X. In fact, it can be little h because big H is Hamilton. So hopefully you can see here that having a diagram changes this whole thing, right? It's just a confusing pile of words when we first start, but we just slowly educate it. Sometimes maybe you don't quite get your assumptions right. Sometimes you got to double check, but eventually you have a nice diagram, and I think you probably know how to solve this now with the law of cosines, right? You're just going to plug in your h squared equals 75 squared plus 120 squared, 120 squared minus 2 times 75 times 120 times cos 40 degrees. Boom, you're done. Okay, so that's how to do that. Take a try at that. We'll come back and do some more of these on Monday. We'll also take a look at some of the key questions in here. So if you are looking at them over the weekend, you're welcome to look at them. You can probably solve some of them now. But if there's some, especially the word questions, the golf one or the Uxbridge one, yeah, see, there you go. The key question, page 31, they say northwest. That's where they don't tell you it's 45 degrees. But we'll come back and we'll do the diagram for that on Monday. Okay. So that's it then. Until Monday, we'll just leave it there. Have a great weekend. Bye now.